Hello and welcome. Okay, let's be honest. You hear the terms artificial intelligence, machine learning, and deep learning thrown around all the time, right? Sometimes it feels like they all mean the same thing. But what do they actually mean? Well, today we're going to cut through all the buzzwords and really get to the bottom of what makes these incredible technologies tick, and more importantly, what makes them different from each other.
I mean, think about it for a second. How on earth does Netflix suggest that perfect documentary you didn't even know you wanted to see? Or how does YouTube line up a video that it just knows you'll love? It can feel a little bit like magic, or maybe even mind reading, but it's not. It's some seriously powerful technology at work, and we're about to pull back the curtain and see exactly how it all happens.
So here's our game plan. First, we're going to start with the big picture. AI is all around us. Then we'll look under the hood at its engine, which is machine learning. After that, we'll get into something really cool and inspired by our own brains, deep learning. Then we'll put the two head-to-head to see the real differences. And finally, we'll try to peek inside the infamous black box that makes this tech so mysterious. All right, first up, let's get our heads around the massive world of artificial intelligence. You gotta understand, this is the foundation for everything else we're gonna talk about today. So what is AI really? At its heart, it's just this huge, broad idea of making machines that can think, that can learn, and that can solve problems kind of like a human would. Think of it as the giant umbrella that covers all the smart tech we use every single day.
And this isn't some far-off sci-fi concept. It is already here and it's everywhere. Netflix, for example, uses AI to scan through millions of viewer reviews and social media posts to figure out what its next hit show should be. In the gaming world, a company like EA uses it to chew through player feedback to squash bugs and just make their games more fun. And yeah, of course, there's YouTube, using AI to build that perfectly curated feed just for you. Okay, so if AI is the whole car, what's actually making it go? Well, that would be its engine, machine learning. This is where the learning part of artificial intelligence really comes to life.
Now, this is the key idea. With machine learning, you don't give the computer a strict set of rules to follow. Instead, you just feed it a ton of data and let it figure out the patterns all by itself. In a way, these systems literally teach themselves how to do something. And the scale we're talking about here is just mind-blowing. Take YouTube's recommendation system. It's not some static program, it's alive. It's constantly evolving by learning from over 80 billion pieces of information or signals every single day. That's how it just keeps getting scarily good at knowing what you want to watch. So what exactly are these signals? Well, they're you. They're your actions. Every single time you click a video, how long you watch it, if you share it or like it or even hit the dislike button, all of that is data. It's all just feedback that the machine learning model is using to get a better and better idea of what you actually care about. Okay, now we're going to go even deeper. Inside the world of machine learning, there's this incredibly powerful subfield called deep learning. And what makes it so fascinating is that it takes its inspiration from the most complex computer we know of, the human brain. See, deep learning uses what are called neural networks, and they're basically designed to mimic the web of interconnected neurons inside our own heads. It's this complex, layered, brain-like structure that gives deep learning both its incredible power and its name. The real magic is in how these layers work. The data gets passed through layer after layer, and each one pulls out more and more complex patterns. This is what lets deep learning models make sense of really messy, unstructured stuff, like raw text, images, or sound, in a way that traditional machine learning just can't handle. And just to give you a sense of the sheer complexity we're talking about, let's look at GPT-3, probably one of the most famous examples of deep learning out there. It has 175 billion parameters. You can think of each parameter as a tiny little knob that the model can tune. During its training, it adjusts all 175 billion of these knobs to capture an unbelievable amount of detail from all the data it sees. And because it's so powerful, research in this area is just exploding. I mean, look at this chart. It shows the growth in just one tiny, specific corner of deep learning. And it saw an average annual increase of nearly 450% in published research papers over just a few years. The whole field is moving forward at a pace that's just breathtaking. Okay, so we've talked about both machine learning and deep learning. Now let's put them side by side so we can really hammer home what makes them different. Here's the number one, big picture difference. With traditional machine learning, a person, a data scientist, often has to manually pick out the most important bits of the data for the algorithm to pay attention to. But with deep learning, the model figures out those important features all on its own, and that's exactly why it's so good at handling super complex stuff like images and human language.
Let's break this down even more. Look at the data volume here. Deep learning needs absolutely massive data sets to work well, whereas machine learning can often get by with less. That's connected to the next row, human intervention. With ML, a human expert is often in the driver's seat, but DL automates a lot of that work thanks to its complex neural network brain. And because of these differences, they're good for different jobs. You might use classic ML for something like analyzing customer reviews, but for a really tough task, like recognizing faces in photos, deep learning is the undisputed champion.
But, and this is a big but, with all this incredible power comes a really significant challenge. The very same complexity that makes deep learning so amazing also makes it incredibly hard for us to understand. This quote just nails the problem perfectly. We can see the data we put in, and we can see the answer that comes out, but the actual decision-making process happening inside a deep learning model can be so twisted and complex that it's basically a black box. We don't always know how it got to its conclusion. And that's where this whole new field of explainability comes in. The goal sounds simple, but it's unbelievably hard. To just answer the question, why did the AI do that? It's all about trying to make these mysterious systems transparent, and that is absolutely crucial if we want to trust them, make sure they're fair, and hold them accountable for their decisions. So how in the world do we peek inside this black box? Well, researchers are coming up with some really clever tricks. One method, called LIME, kind of asks a simpler, easier to understand model to explain what the super complex one just did. Another one, SHAP, actually uses game theory to give every piece of input data a score, showing exactly how much it influenced the final decision. Pretty cool stuff. So let's wrap this all up. AI is the big overarching idea. Machine learning is the engine that actually learns from data. And deep learning? That's the supercharged, brain-inspired version of that engine that can do some truly incredible things. But the trade-off is that it's a whole lot harder to understand. And that leaves us with a massive question for the future. As these black box systems get more and more powerful, maybe even more intelligent than we are, how do we make sure we can keep them pointed in the right direction? How do we steer them toward outcomes that actually benefit all of us? It's honestly one of the most important questions of our time, and something we're all going to have to think about. Thanks so much for joining me.